Welcome to another CO2 Monday. I'm your host, Trevor Matthews, and I'm super excited. We have a big event today. I'm here in Milan, Italy at the Frascol factory, here with my good friend, Maurizio. How you doing?
Fine, thanks, and you?
Maurizio is the lab test manager, is that correct? And you're taking care of all the performance tests, reliability tests, and diving in to get a better understanding of the compressors, because I love learning more about compressors and how they work. And what's really important to me is understand the quality control. How will they work under the pressure in the field? Because we know technicians in the field sometimes do not either install, commission, or set them up right, or the end user doesn't allow the contractor to properly maintenance or service those compressors. Maurizio, welcome to CO2 Monday.
Welcome. So now we are here in Frascol in the R&D Lab. Here behind us is the CO2 test rig of Frascol. It's a real calorimeter in which we can perform both subcritical and transcritical tests. This kind of test rig is highly designed for making performance tests, but mentioned by Trevor, also reliability test. We can test vibration, we can test noise, and also pulsation, everything that is important for a plant. In this case, we are also testing the oil carryover of this SK compressor. This is one of the smallest of our series. It's a 2-cylinder with a 2.5 horsepower motor. In this case, we are running the compressor with inverter at 50 Hz, but we can do performance test and reliability and every test from 30 to up to 70 Hz, but also more in the frequency and lower in the frequency.
Yeah, and this is what's so great about it is that when you work with your manufacturers and find out how they run their compressors, how they get their compressors to work. How long have you been with Frascol?
I'm in Frascol from February 2017. I work in the technical department for 3 years as a technical specialist and developer of the Frascol selection software. So I manage the raw data coming from the lab, awesome. And I perform the calculation to obtain the curve, so the polynomials of the compressor, in order to calculate the performance of the compressor not only in the tests in the same point in which we can do the test, but in all the application envelopes. So using these polynomials, we can simulate every plant in every condition. So it's important also for the customer to understand better the behavior of the compressor in the condition that he needs.
Yeah, and that's what's super important. I talk about this time and time again, is that you need to get into the compressor manufacturer software, and that's really where you start to learn, because you put the design conditions that you're actually working at, and you need to stay inside those design conditions. Because I'm assuming that your compressors, when you're testing here for reliability, you have an operation envelope, right? And you're trying to push that compressor to the limit so you guys can make sure that you have the correct operation envelope. So when you put it in the software and someone put the conditions in, they stay inside that envelope. Do you want to talk about the envelope a little bit?
Yeah, of course. Here in the lab, and when we develop a new compressor series, we check the maximum and the minimum condensing, both evaporating condition that allow us to be safe in functioning for the compressors. The important for us is that if you work inside of the application envelope, you can be sure that the compressor will work safe and stable for a very long period. But to be more sure, we also try to push over the limits. So we try to go over the maximum delta pressure of the compressor, over the maximum discharge temperature, and we check which is the real limit, in order to be sure that if you stay with the safety threshold under this limit, you will be safe in the functioning of the compressor. We can do the reliability test both in this test rig, but we have also other 4 test benches in which we can perform reliability test for thousands of hours, because this test rig is specifically designed for performance test. So it's better for us to use it to improving the efficiency, to improve the performance of our compressor than to do reliability tests.
So some of the other benches you have would be like maybe a short cycling test, how many times it starts and stops to see how long it will run, start and stop, or overheating compressors for running a flood back, for an example. Is that some of the other test benches you have?
This is something similar to what we do. There are 2 different plants. One that is similar to a real plant, because we have an oil separator with the oil regulator. So we have the oil management for the compressor, and we try to simulate quite stable condition, but with the highest delta pressure, with the highest temperature in the discharge. So we have the highest temperature inside of the crankcase, so we have the oil that is in the worst condition with the same worst condition for the lubrication of the compressor. So the highest stress with the worst condition for the oil. And we check if everything is okay. So we run the compressor for thousands of hours, and then we open it, we check every component, we check the wear on the connecting rod, the pistons, everything. And then after thousands of hours of test, we know where we can go up to which condensing pressure, which is the maximum discharge temperature.
And so this is why it's so important when you're out in the field or you're working or testing compressors and one has failed, you need to look inside, and they do testing and you can see certain wear. I talk about this all the time. If you have major overheating, you're gonna see a lot of carbon, a lot of black on the top. Maybe your cylinders are wore up and down. If you have flood back, maybe that main bearing starts to wear. And these are telltale signs why you have to, as a technician, especially if it's out of warranty and it fails, you wanna make sure the next one you put in is not gonna fail. So why don't you walk me through what's going on in this reliability test?
Yes. In this case, as mentioned before, we are running the compressor at 50 Hertz. So we fix a condition, and in this condition, we check the oil carryover. This is important because we have to be sure that the oil that comes out from the compressor is the minimum. And in order to be sure that the correct amount of oil remains and lubricate all the components, mechanical components of the compressor, and also to be sure that this oil does not go inside of the plant of the customer in order to maintain optimal performance of the evaporator and all the components that is better not to go some oil inside.
Yeah.
In this case, we have a mass flow for the oil return. So we check how much is the mass flow of oil at every calls back of the oil regulator. So we have an oil regulator inside that maintains the correct amount of oil inside of the oil, the carter of the compressor. And every time it calls back the oils, our mass flow measure it. So we can exactly knowing which is the mass flow of the compressor, which is the oil carryover fraction inside of the compressor. We know that this value it can be a fixed value because depending on a lot of factors, the superheating depends on especially on the speed, the rotational speed of the compressor. Because running the compressor at 30 Hertz will bring a very lower oil carryover. Running compressor at 70 Hertz, it's normal to have a very higher oil carryover. But it's something that we consider, and we have optimized all the components inside, the oil, especially disc, the position of the oil set glass. So everything inside is optimized in order to be sure that the oil carryover is the minimum that we can.
Yeah, and this is why it's so important to work with your manufacturer and find out how they run their compressor, because oil is one of the most important things in the compressor for lubrication. If you don't have lubrication, you're going to have a seized compressor. And just like Maurizio said, is that when you've got a variable speed on your compressor, you start to ramp it up, ramp the hertz up, it starts to speed up, so you got more mass flow going, and so you got more oil carryover. And so what are some of the things of if you have too high of oil carryover, what could that cause with your compressor?
As mentioned, the compressor could cause too much oil carryover if this design is not totally optimized, but also some case of wear inside of the cylinder benches. So if the piston is too weird, the rings of the piston are there is too weird inside of it, maybe you could have too much oil carryover. So you have to check it if you want to be sure that everything works fine.
Yeah, so if you have high oil carryover and it starts to have wear, like he says, then potentially you could have some blow-by. So as that piston pushes up, that discharge goes back into the cylinder and you get that wear, and that's what you don't want. What about low oil carryover? So you're running it, and I believe you said 30 hertz to 70 hertz, but what if you run it at 20 hertz for a long period of time? What could happen at that point?
For the oil carryover, is not a problem because you have in the majority of the plant, in the application of this kind of compressor, you have an oil management that guarantee you to have the correct amount of oil inside of the carter. But maybe running the compressor at a low, very, very low frequency for a very long period maybe could bring you to some problem in the cool down of the windings. In this case, we check it because we try to push the limits. So we check if that minimum frequency of the compressor in the condition where the mass flow is the minimum, if the temperature of the winding is correct. So we measure the PTC, temperature sensor that is placed inside of the wiring, and we check if the threshold of the intervention of the motor protection is reached or not. If it's reached, maybe we can optimize it so we can correctly modify the design of the pockets around the stator of the motor in order to be sure that the correct amount of mass flow cool down the windings.
Yeah, and that's a big thing. When you start to slow down the mass flow, it's different than their Capiflex or their different designs where it's capacity controlled. This is actually slowing down that gas, and now you start to overheat, which could lead into an overheat issue, could lead to a failure or wear on your compressor. So this is why you want to go into their software. You want to find out in their manuals on that range of hertz that you can use.
Yes,
because
the frequency range is something that is nominal. So the most range of our compressor normally goes from 30 hertz to 70 hertz. Yeah. But in some particular series or in some particular motor, we can go up to 87 hertz or down to 25. It's important to check in the software, as mentioned, because here you can check exactly the condition in which the compressor will go on the field. So if the software allow you to use the compressor at this frequency, means that also in the field you will go with that frequency in the field. But because there are some occasions, some particular point of the application envelope in which maybe you can't reach so much frequency, so the highest frequency, because of the current that is maybe could be too high, so or the windings could be too hot. So if it's better for you to check in the software, and you will see if you can work in it or not.
Yeah, no, and that's so important. Once again, I already said get into the software to learn it. And that's where you're going to find out the most information about the compressor itself, the operation envelope, the polynomials, and we'll get in a minute, as well as like the discharge temperature at those conditions, which is really cool because that is one check that you have to do when you're working on compressors. When you're doing a service or maintenance, you need to do that discharge check. Yeah. When I take a look at it right now, I see that it's right here, that it's really frosted up. A lot of people would say, oh, I'm flooding back or liquid's coming back to the compressor. Is that happening right now?
Yeah, and this is just an ice that is caused by the fact that we are running the compressor at minus 20 degree evaporating with 10K superheating, so 18 Fahrenheit, right?
Good, yes.
Yeah.
Okay, yeah. Awesome.
And in this case, so the moisture that is present in the air will ice in the contact with the tube. So you see that just the suction line and a portion of the motor side of the compressor is iced. And this is normal because you have a very, very low temperature in the suction of the compressor, and it's normal to create the creation of ice. You have to worry if you see some ice in the head, because this means that really some liquid is coming back to your compressor. Depending on the application, but normally it's not so okay. Also, the carter is better not to see ice on the cylinder side of the housing of the compressor, because in the carter you have the oil, and it's better to keep the oil temperature more than 40 degrees, something like this, so because of its viscosity. Otherwise, the lubrication of each component could be not optimized, we can say, because it's too high viscosity and the lubricant does not flow so easily in every point of the compressor.
And that's a great point. So we see it's frosting up here, but it doesn't mean you're flooding back. You need to get your tools out. You need to use your pressure gauge, your temperature probe, and actually check what is actual superheat coming back to the compressor to make sure that you're not flooding back.
Yeah.
And so you said 10K or 18 degrees Fahrenheit on this compressor model.
Yeah, in this case we are using this kind of superheating because of performance measurement reason. In Europe, we have a normative that suggests us the condition in which you have to calculate the polynomials. For CO2 subcritical and both transcritical, you need to perform tests for certification and polynomial calculation reason at 10K superheating and 0 Kelvin subcooling. But for application reason, maybe you could have also 20K in superheating and a different condition in all the plant.
Yeah. I do notice rack manufacturers, they usually have like a higher superheat, so like they're a bit more safer or secure. Yeah. So like I've seen a lot of them where they would say, like you guys would say 10K or 18F, but you go into the rack manufacturer, they'd be like maybe 18K or 20K. So it all depends, because they want to be safer. They want to make sure that that system is going to last a long time, because you guys build the components, then you sell it to an OEM that builds the actual refrigeration system. So it's always good to look at what the compressor manufacturer does, as well as the manufacturer of that equipment. You got to read the manuals, get into the manuals, read the manuals, so you understand what both manufacturers recommend. I always go back to the compressor manufacturers to see, but I follow up with the OEM of the compressor, because it's so important. You guys do all the testing.
Yeah, of course.
And a lot of your manufacturers will be doing the tests on their equipment as well, because
all good manufacturers there are testing their equipment and making sure it's going to work when it gets into the field.
Yeah, of course, very important. Regarding the measurement of the compressor performance, here we measure the most important things that are the power supply to the power consumption of the motor, making thanks to a wattmeter. We measure the condition that needs to be very stable. So we have two pressure transducer, one in the suction line and one in the discharge line, and two temperature probe that are PT100 sensor that are very precise for the measurement of the suction temperature and the discharge temperature. We also put a PT100 sensor inside of the carter because of what we mentioned before. So we want to know which is the real temperature of the carter in every condition, because we need to know which is the temperature of the oil, because the most important topic for the correct functioning of the compressor, because the correct lubricant temperature is very important to guarantee a correct functioning of the lubrication system inside of the compressor.
Yeah. Because it's very important. You don't want your oil too cold or you don't want it too hot.
Yeah.
Because if you get it too hot, you get to a certain point where it stops lubricating, it starts to break down. And it's important that you're in the right range, because if it's too cold, it gets thick, it doesn't move properly. If it gets too warm, it gets really thin, and then the oil separator can't separate it, and then that's going potentially in your system, or you're starting to lead to wore parts or worn cylinders.
Yes, exactly. In this kind of test rig, we also, as mentioned before, test the pulsation. That is another very important thing for our our customers. In this case, we have a particular design of the head that guarantee a low level of pulsation. With a higher volume in the discharge side, we guarantee a low level of pulsation. But it's something that is better to see in the field, because here in the plant, the piping is different, so everything is different, and we could never see exactly the same of our customer.
And so you want to explain a little bit to everyone what pulsation means?
Yes, it's something related to the mechanism itself of the compressor. So you have an alternative movement of 2, 4, 6 pistons that make a peak of pressure inside of the discharge side of the head. So this peak of pressure could be more or less higher than, and we can regulate the highest of this peak, managing the volume in the discharge side of the compressor. So designing correctly the head, in particular the discharge side of the head, we can manage correctly the pulsation of the compressor. That is something that you will see, a customer will see in the plant when he will see, I don't know, the tube that maybe are vibrating, or do you see some strange, something like this. Header. You have to be sure that it's pulsating and not vibration, but it's easy to check, because you will see if a compressor is vibrating or not. And if you don't see a compressor vibrating, but your piping is vibrating, maybe it's something related to the pulsation.
Yeah. And that's a good point, especially when you have drives, VFDs on the compressors, is that depending on what hertz or what frequency, you could get vibration. So it may not be the pulsation, it could be vibrations from the drive. So you want to understand where it's coming from, and you test for pulsation. So you make sure that when your customers get it, there's no pulsation, or
the minimum that we can do. We measure it on the discharge valve. So it's not, we can't measure on the tube, because maybe the tube that will use the customer is different. So we measure it inside of the head, or maybe on the discharge manifold of the compressor. So where is our competence, we can say.
No, that's awesome. So you talked about polynomials earlier.
Yes.
And I don't know much about polynomials. We want to explain what that is so everyone gets a better idea.
Yes, of course. Polynomials are a software equation that allow you to calculate most important parameters of the compressor. The most important two are the polynomials for the refrigerating capacity and the power consumption, that allow you to calculate the performance in terms of cooling capacity, coefficient of performance, and the electrical consumption. Polynomials are made by 10 coefficients and are calculated with at least 11 points inside of the application envelope. Normally, we do at least 20 points, because in order to be sure, and we check all the application envelope and maybe a little bit more, to be sure that inside of the application envelope, the reliability of our polynomials is very high. These polynomials could be used directly in our software, so without making any calculation. Automatically, you can set the evaporating temperature, the condensing temperature, and the software will calculate using these polynomials the performance of the compressor. But you can also take it, so you can put it in your Excel file or in your calculation tool, and you have exactly the calculation of the performance of the compressor. So maybe you have also the polynomials of other components inside of your plant. So in exactly the point in which you will be running the plant, you will have the performance of the compressor. And it's very important to know if the compressor is the right model for you. Maybe you could choose a smaller one, a bigger one, and maybe you need to run a VFD in order to use a higher frequency or lower frequency. Using the software, using the polynomials allow you to understand it better.
Yeah, and that's really key to understand. So for me, engineers, designers, they would use the polynomials when they're designing a rack. And in the software, that would be great for the designer. And I want us to jump on the software in a second. But then in the software for technicians, it will be the operation envelope, the discharge temperature, the conditions. Because what's so important, I talk about this time and time again, you need to get in to the softwares and put your suction, put your discharge, put your amps to make sure it matches up to your performance test. Because if you put the condition in, you put your suction, you put your discharge, and all of a sudden your discharge heat is way too high when you measure it, or your amps are way too low with those design conditions, there is probably something going on in that compressor.
Exactly.
And this is why you build software, so people can go out and do the testing. Why don't we just jump on that software and take a quick look?
Yeah, this is the selection software of Rascold. In this kind of software, you can perform calculation with all our compressors. So not just subcritical or transcritical CO2 compressor, but all standard reciprocating compressor, screw compressor for compact screw or refrigerating screw, so without integral separation. In this case, we have pre-selected SK series for CO2 subcritical, and we have pre-selected the A2.5 minus 5 SK3, that is the compressor that is running behind us. Here you see that we have selected this kind of our supply of the motor, so it's 463 phase 60 Hz. This is common in North America, but you can also set other power supply and will be available also for Canadian and 565 3 phase 60 Hz. Here is the only refrigerant for this series, but for different compressor you can choose from a wide range of refrigerant. This is the place where you set the condition of the suction line, so the evaporating temperature, in this case minus 22 Fahrenheit, the suction gas superheating, 18 Fahrenheit as mentioned before, and the amount of the superheating that is inside of the evaporator, so the useful fraction of superheating. In this case it's 100%, but it's just for easier for us. In the right side, you will see that there is the condensing temperature that you can set. In this case, it's 50 Fahrenheit, and the amount of subcooling. Down there is the compressor. You can choose more than one. So in a rack, maybe you have probably one compressor that is the lead compressor, and you can run it variable speed. So you can modify the frequency of the compressor, and you can add also the number of the fixed speed compressor.
Okay, great.
Here below, you have the application envelope of the compressor, and you have the red point that indicates you where you are inside of the application envelope, and allow you to understand if you are at the limit, so in a condition in which you could have some critical issue, or in the middle, as this case, so you don't have any problem.
Yeah, so that there is really key. That operation envelope, we need to stay inside there. As a technician in the field, or even a manufacturer building their equipment, they need to stay inside that, because if they start to run outside, too high condensing, too low suction, too high suction, that will start to lead to wear in the compressor, which will lead to a shortened life of the compressor.
Exactly. Maybe you could have too high temperature that burn out the oil, or maybe too pressure that causes too high wear, something like this. So it's important to be inside of the application envelope. Also, if you see that you are working outside the application envelope, but maybe something in your plant is not working correctly, so the compressor can stay inside of a safety condition functioning.
Awesome.
The right side, you have all the calculation that the software do it automatically. So the refrigerating capacity, the power consumption here, and the current, as mentioned before, the driver, that is very important for and easy to measure, because it's very easy for a technician in the field to measure the current of the compressor.
These are test points. So you got minus 22F for your evaporator, you got 50F for your condensing temperature, and then it calculates what that current is. So you should be running around 15 amps. You know, you probably have a plus minus. Is a plus minus of 5% or something like that? What is your range? So 15 amps, that compressor will be working fine.
Fine, yes.
Yeah.
I think so depending on how much is the current, with 15 amps, 1 amps, more or less, it's okay.
Yep.
Maybe if you are on 100 amps, 1 amp, it's easy that we can make an error of 1 amp. So it's not right. But maybe if you see 10 amps less, maybe it could be
definitely want to check what's going on, right?
Exactly. Another important thing is the discharge temperature is down there, and other thing that's maybe could be interesting to check.
Well, that discharge temperature is huge, right? Because you're running inside those conditions. Where would they check it from the discharge? How far would you recommend a technician to check that discharge temperature? 60 to 150 mils? How far?
From the discharge of the compressor.
Yeah.
In inches, I don't know exactly. It's a 15 centimeter. I think that's a 5 inch.
6 inches, 150 mils.
Something like this.
Yeah,
okay.
perfect. So you'll check it there, and in these conditions that we're looking at right now, it would be 198 degrees Fahrenheit.
I don't know exactly how much it is. I think it's down than 100 degrees Celsius. But it's important to see also if you use PTC discharge temperature to check if it's correctly wired and if the compressor motor protection give you that in the recording memory of it has any discharge temperature alarm. So if you check it, you could know if sometimes the compressor has run in a condition that the discharge temperature were too high.
Yeah, okay, what else?
Also, there are some other important things inside of the info button. Let's open up another sheet in which there are possibility to calculate performance in all the application envelope. So in this case, we are running the calculation directly, and you see moving the evaporating or the condensing temperature. You see how much is the refrigerating capacity, the power consumption, and also the coefficient of performance. Wow. So it's easy to know for you. I'm moving to an higher condensing or a lower evaporating temperature. You see, the COP is reducing or something like this. You can also calculate discharge temperature, current, everything you want. This is a focus on the operating limit, so the same but it's quite bigger. Here there are the polynomials.
Okay.
So these two, the refrigerating capacity polynomial and the power input polynomials, are the 10 coefficients that allow you to calculate everything about the compressor. And this below is the equation that you have to use. It's not important that you know how to use it because the software automatically do it for you. But if you want to do better calculation, to better simulation of your test rig, especially in engineering department, technical department, this is something that is important to you to understand and to use because it's the best way to simulate our compressor. There are also some other information, technical data, so the maximum current, the weight, the dimension, the sound level, everything about the compressor. So you need to install it, you need to check if the compressor is the same, so the position of the valves, everything is inside of it. And there are also the links to all our documentation. That is what you mentioned before. It's important to read the OEM to our customer documentation, but if you want to make sure that everything in the compressor is important, it's better to you to read, to understand our installation and startup manual, everything, because we test everything about the compressor. Maybe our customer don't do this because its business is to build the rack. Our business is the compressor, and we know better about it and about the functioning and startup and everything. Yeah,
and that's so important. It's all about reading the manual. You got to get in there, and it's in info and then documentation and download the different manuals. And there's sometimes more than one manual. So you read that one manual, but then if you have with a drive on it, a variable speed drive, you might need to check that one out. If it's a capacity control like Capaflex, maybe you got to read that one. It might be a separate manual. There could be 3 or 4 manuals for one compressor. So just be aware to go through all the different documents, give you a better idea on like the operation, the installation, the maintenance of that compressor. Fantastic. Is there anything else in the software you'd like to show?
I think that the most important topic has been explained, so we are fine. You can print, you can export, you can do whatever you want with the software, but I think the most important thing has been explained.
That's awesome. This is what good manufacturers do. They test their compressors before they get to the field, before they get to the OEM. I've been through the whole facility. They got an amazing facility here. It was super cool. And if you ever get a chance to get out to meet a manufacturer like this and see what they're doing, it makes a world of difference. It gives you that confidence in what that supplier is doing. Because I know I've seen it time and time again, and even I've said it when I was in the field. I got a compressor, I put it in, it didn't work. Oh, it's a DOA, or dead on arrival, or it doesn't work from startup.
They test it and they run it before it leaves. And great manufacturers, just like Frasco, they all check it and they make sure. So when you're in the field and you have a compressor that's not running and it's a brand new compressor, there has to be a reason why. Are you making a mistake? Things do happen. There's errors that do happen. They could fall off a truck and it gets banged up pretty bad. Or you put the wrong voltage to it. I've done that before.
Yeah, it could happen also in the labs. Everything could happen. You have to, as mentioned, read everything, know what you are doing, measure if you are going to a plant, to a compressor that is running, measuring the condition in which it's running, checking with the software if everything is okay, and then you can do your best to understand the behavior of the plant.
Yeah, because you can do your best. You can be there and service it properly, maintenance it properly, but storms happen, for example, you know what I mean? Or when the seasons change and all of a sudden the condenser gets plugged and you're not there in time and you start outside the operation envelope. So there's all these little things. Anything else you want to talk about this or let everyone know about this unit?
Yeah, I focus more in the calculation of the performance of the test rig. This test rig is a certified test rig, so every year we check all the pressure and the temperature probes. We check the mass flow meter, we check the watt meter, and we make the performance test of the same compressor every year to check that all the performance that we measure are reliable every year, and every year we can reach the same results, because it's important for us to be sure, both for us and for our customer, because for us it's important to know if we are currently improving the performance of the compressor, so to know that many years ago we make a compressor that maybe has a lower efficiency, lower capacity for the same displacement, and for the customer, because they know that the performance that they can have on the software, or maybe that we can share with us to the technical department, are reliable. So they know that if we say that the capacity is a certain amount, that is quite sure.
Yeah. So this is a CO2 test bench. Do you have other natural refrigerant test bench here to test your compressors?
This is a CO2 test rig. As mentioned, we have other 4 test rigs for CO2, and we have also another test rig for propane application.
Awesome.
Yeah. It's quite new. It's 2 years that we are starting testing very deeply in the propane application, both for chillers, both for heat pumps applications. So we are pushing up the limit, because the requirement of the market is to pushing up the application of heat pumps at always at an higher temperature. It's something that we are trying to figure out. So it's something that we are working on. It's very interesting because before the building up of this test rig, we just can make a simulation, can make calculation, but there is nothing better than a test and with the same gas, with the exact oil, because you can simulate correctly the correct interaction, the real interaction between the lubricant, the refrigerant, the compressor. There are some aspects that you can imagine, but you can't really understand how much is it in the reality. So it's something that we are very proud of it, because it's very interesting and is bringing us very, very good results. So in improving performance of our compressor.
And it must be pretty cool for you, because it's not just the same thing, Dana. Now you got propane, you got probably other refrigerant testing, so things are just changing all the time, and that's probably exciting when you see something going on and you're learning about these new refrigerants and making a difference, right, in the performance of your compressors.
It's very interesting also because you see that the product is growing up, because every year, every day you make tests, you improve everything of the compressor itself, and it's something very interesting and very stimulating for me. Yeah. And also for the other guys in the lab and the technical department.
It's like something new, So if someone wants to find out more about your software, they want to learn more about Frasco, where would they go? To the website?
Yeah, we have to go to the website of Frasco, in which you can download everything, the software, the manuals. Yeah. You have an overview of all our products, divided by application or by product you already know us, so you can easily find your model. If you are behind the compressor, you just have to insert the product name of the compressor inside of our website, and you will be linked to all the documentation. This is very important because you are easy to understand and to download everything to learn everything about our compressor.
Yeah, so you're going to want to go and head to their website, get the software, download it, and play around with it. Start to learn, because until you play around with it and you use it, that's when you start to learn about it. Get the manuals, read the manuals if you were working on these compressors. And it's going to give you a better idea on how they do it and how they design their compressor, how they run their compressor, install it, maintenance. I'm going to put the links in the show notes, so check the show notes out for the website link to get the software. Got a couple questions here, it looks like maybe.
Is there a low temp compressor that can operate at higher ambient temps? It's a good question.
I think how much is the high ambient temperature? Because normally we have a single stage or two stage compressor, for example, for standard refrigerant, but also CO2. In our application envelope, CO2 goes down to minus 50 degrees Celsius evaporating, but our two stage compressor for standard application, for standard refrigerant, goes to minus 70 degrees Celsius evaporation. And normally, as we use everywhere, in summer also, depends on how much is the highest temperatures, because I think that 40, 50 degree could be something that you have to manage. We can manage with our compressor. Normally, it's important for you to correctly design your unit because of the higher ambient temperature, bring a higher condensing temperature, so higher discharge temperature. So the important is to be in a condition inside of our application envelope.
Yeah,
if you can stay inside of the application envelope, also with high ambient temperature, no problem.
Awesome. Well, one more question. Is there a difference in HFC and CO2 compressors for oil management?
Yes, I mean, the technology inside of the compressor is the same. So we have compressor with oil pump and we have compressor with oil splashing disc. Yeah. So the technology of the management of the pushing the oil everywhere inside of the compressor where we need is the same. Also the design of the lubrication channels, everything inside is quite the same. For CO2, given that the fact that we have a higher stress in all the components, thanks to the high delta pressure, we manage an optimization of the lubrication system in order to bring the correct amount of oil everywhere. Also, the components are different. You know better than, as I know, that the pistons are different, the connecting rods are different, the bushing are different. Yeah. Everything is different because of the wear of that the CO2 brings to every component. So the mechanical of the CO2 compressor is quite different from a mechanical of a standard refrigerator compressor. But the technology, we can say, is the same. So it's just an optimization of a product that we know from 80 years or more, 90 years from now.
Awesome. Once again, you want to check out their website. You want to learn more, head to the Refrigeration Mentor's website. Check this out on YouTube. Listen to it on Spotify. Thank you so much for taking the time to be here with us. And let's get a conversation going.
Hey, thank you for watching this video. I do hope it is bringing you a lot of value. If you are looking to grow and build your refrigeration teams and want them to learn CO2 refrigeration, head to the refrigerationmentor.com website, click to contact us, and let us know how we can build a culture around training inside your organization. Let's get a conversation going.